Okay, so welcome back. So we are going to be doing review lesson part 3. So in case you don't remember, for the last 2 weeks we've kind of just been going over um, the various ways you go over and you solve a Python problem. And in the last one, what we went ahead and did was like a more practice problem. So we went over to list 1, and so we did one problem over there. So again, if in case you guys don't remember, the very basics of a Python program, um, when you go ahead and write it, first of all, you want to write down your pseudocode. So the logic that you'll take in order to go ahead and solve the problem eventually, right? And you also will want to remember um, the how each like kind of line of code really works, how to simplify like common bits of code that you'll see again and again over time, as well as there's many different strategies essentially that you can go ahead and take. This is just when programs start getting hard, taking these steps will relieve your stress, I guess, because these are kind of slightly easier to understand. And again, when it's easier to understand, then you feel more comfortable doing it. Again, I perfectly understand how when you go ahead and you program it your first time, you won't necessarily understand how to do it, but you'll see like the different steps that we take and you'll understand that. And again, this is learning from experience. You won't actually get like super good at it until you've done it so many times you can't even count, right? And in that, I guess, department, it becomes almost a sort of a, it's just intuition at that point, and that's the goal when you're a programmer. That's what you ultimately want to achieve, where all these algorithms, it's essentially no longer complicated for you, because instead what's going ahead and doing is you are just able to understand all these concepts and effectively use them. Now, on top of the different strategies that we learned we can use, we also touched on debugging. And so debugging is very simple. Uh, it's essentially just going ahead and whenever you run your program, you're obviously not going to always get it correct the first time. And it's important to get it wrong, actually, because when you go ahead and you get it wrong, you can better understand how your code will exactly work. And when you can better understand how your code exactly works, then that means that you're able to not only learn from that experience, but also begin to understand these different types of errors so you won't make the same mistake again. So we learned about the different types of errors, debugging, all that stuff, and it's important again that you review over this. Even though this is an actual technical programming, it's very important you learn this, because by learning the I guess strategy behind this, uh, you can whenever you write a program, it's a lot more efficient than having to say like Google, how does this error occur and how can I fix it, right? We're bound to have multiple errors. Not all of them are going to be syntax errors. We mainly touched on syntax errors last time, but the other errors include like logical errors. So say your code runs, but it just does not give the output that you want. So that would be a logical error because it just does not complete the logic flow that is required, I guess. And again, this is perfectly fine. Uh, it's just that sometimes these can be a little harder to detect because it won't be like error on line 60, because it might be an entire function that you wrote wrong, or it might be a line out of place. So you'll learn how to correct these mistakes over time, and I would say when you write your program, it'll take about a tenth of the time, and debugging will take about 90% of the time. And that's just pretty much how it is. Because the longer your programs get, the more mistakes you'll make, no matter how experienced you are, right? like no matter how experienced you are, you're bound to make mistakes no matter what. And it's important to not get, I guess, discouraged by these mistakes, because everyone is going to make them. So, we can go ahead and we can move on to coding that. So, we can go ahead and jump into Python. So we did string 1 and list 1, so we're moving on to logic 1, so we're going to look at near 10 here. So I want you guys again to do the same process. Do these read the instructions here, and then go over these practice cases. And we'll come back to that in about a minute or so. Alrighty, so hopefully you guys have been able to go over the instructions over here. So it says given a non-negative integer num. So we should probably just go ahead and write this, because you are given this num. There, so given a non-negative integer num, return true if num is within 2 of a multiple of 10. So we can go ahead and write return true if num is within 2 of a multiple of 10. Quite literally the instructions, right? Note, a% b is the remainder of dividing a by b, so 7% 5 is 2. So that's a little tip, right? Now, sometimes CodingBat will go ahead and it'll give you this link. These links are very helpful. Now, it'll lead you to a video over here. It's 5 minutes long. Again, each one of these videos, it's fairly helpful. It's a great introduction to the different concepts that they introduce over here, and they'll even show you the problems at the bottom that use this kind of whatever concept they're teaching, and they'll go over in not too much detail. So it's important, if you still don't understand it, you can just go ahead and Google it yourself. Google is the best teacher, no matter what type of programming you're doing. It's kind of a consistent theme, I guess. So what we go ahead and do is return true if num is within 2 of a multiple of 10, right? So since this is our only, I guess, requirements for this program here, it's fairly easy. There is nothing too complicated. So what I want to make sure you guys understand is how exactly this pseudocode would work. So I'll give you guys a second to kind of think about how exactly would this pseudocode work, and how can we turn it into actual code. as you can tell, if num is within 2 of a multiple of 10. Well, there's two ways we can go about this. So we know we can keep this part over here, right? So return true if num, right? So what goes after this? So we learned about this new mod function. So again, this will essentially just give you the remainder. So 10% or 2% 10 would give you a remainder of 2, right? 11% 10 would give you a remainder of 1, etc. Right? There's a bunch of examples that we can go over. It's essentially just a remainder function. Now, from this remainder function, what can we grab from this? Well, from this remainder function, we can see, alright, we can see if the number is 1 more than 10 or 2 more than 10. Right? So if num percent 10 is less than or equal to 2, remember, it's within 2, so it includes 2, right? So return true if num percent 10 is less than or equal to 2. And the else case is just going to be false. So if we were to take away this over here, we would see, alright, if we were to go ahead and run this, we see near 10, 19, and near 10, 158 return false. Now we go like, well, okay, well, why does this return false? If we plug in 19 over here, 19% 10 is 9, so it is not less than or equal to 2. So we have to include the other case in which the remainder is 9 or 8, because 9 is still within 2 of 10, and 8 is also within 2 of a multiple of 10, which is 10, right? So return true if num percent 10 is less than or equal to 2, or num percent 10 is greater than or equal to 8. And we get all of the cases right. Now, a little while back, when we were doing similar types of questions, we learned about the absolute value function. So the absolute value function will essentially just make whatever number we currently have and turn it positive, right? It will automatically just go ahead and turn it positive for you. So whether it be -2, whether it be essentially negative positive 2, it will return 2, right? So this is particularly useful because this means that we can go ahead and keep it in the range -2 to 2. And you may be wondering, well, why exactly is this so useful? Well, if we look at this question more closely, we can see that it wants us to see whether or not this number is within 2 of a multiple of 10. And so as a result of this, this absolute value function is perfect. So instead of having to include this clunky OR function over here, we can just return 10. Hold up. Let me go ahead and test something real quick. But for now, I just want to make sure you guys understand this previous statement. So, I guess Control Z does not work. So if num percent 10 is greater than or equal to 8. Alright, so we can see that this case has worked. So I want to make sure you guys understand this, and then we can move on. Alright, so this is only one line of code, so it's fairly simple. Now, the method I was thinking of was essentially what you would have to do is you do num5 minus num percent of 10, and so what this would give you would be a simplified version, because if we take num percent 10, it will be either 2 or 8, right? So it would be greater than or equal to 3, And so I will run you through the logic momentarily. I believe this is the right number for this. Oh, abs. And see, we get all the cases right. Now, how this logic actually works. So we have num%10, and we know that the successful cases are going to be when the remainder is -1 or 9. So we'll actually just start from 0. We got 1, we got 2, we got 8, and we got 9. So when we look at this and we think about it, alright, well, the two cases that I guess are farthest away from each other, but these ones obviously are smaller than the 2, and the 9 is greater than the 8, so we want in between the 2 and the 8. Then we take 8 plus 2 divided by 2, and we get the average as 5. Now, what exactly does this 5 mean? Well, what this 5 means is that when we take 5 minus 2, we get 3, and when we take 8 minus 5, we also get 3. And if we take 5 minus 1, we get 4, which is greater than 3. 5 minus 9, which is -4, we take the absolute value, and we also get greater than 3, because we get 4, right? And essentially what this does is it uses a problem-solving technique, I guess, using the average and then subtracting it from the greater edges, I guess. And we use this in order to solve this problem. Now, do I recommend you use this method even though this is shorter code than the other method? Not if you don't understand how to properly use absolute value function. So I know this one can be a little confusing at first, so I will let you guys go ahead and kind of review over this yourself for a second, and then I will go over the code, the next question with you in about 1 to 2 minutes. Alright, so I know the concept of absolute value, although it seems pretty simple on the outside, can be a little, I guess, difficult to comprehend and properly use when you actually go ahead and look at it. Again, this will be the same for all concepts, so don't I guess, worry if you don't entirely understand yet. Of course, if you do, I suggest you go ahead and do some practice, because sometimes you might find some holes in your knowledge, I guess. And when you go ahead and you do the practice problems, you will eventually keep on getting better at it until you're actually comfortable enough to use it uh, consistently whenever you need to actually use it. So now we can go ahead and we can move on to the next problem. So we were in logic 2 last time, so we're still going to stick with logic 1. We're actually going to go back a problem, and we're going to go here in 1 to 10, and I'll let you guys read over the instructions for a minute, and then look over the sample cases as well. Alright, so we look over the instructions here, and we see given a number n, return true if n is in range 1 to 10. So I will let you guys go ahead and kind of review over what you think the pseudocode would be for this block of code, and then I will run over the pseudocode with you. This one really isn't too hard again. If you really understand the concept of pseudocode, you should get it fairly fast. If you don't, again, that is perfectly fine, and I'll try and explain it to the best of my abilities, so you don't, so you won't get it wrong again, I guess. Alright, so we have defined in 1 to 10, and we get n, and we get outside mode, I believe. Let me just check that real quick. Yes, we do. Okay, and when we go ahead and we write the pseudocode for this part, we get given a number n, return true if n is in 1 to 10, right? So it doesn't have to look exactly like this, obviously. It probably won't look exactly like this because each person will think differently on how to properly solve this problem, and again, it'll vary, but as long as you understand it and it works, it is perfectly fine. Unless outside mode is true, in which case return true if the number is less or equal to 1 or greater or equal to 10. So, else, false, else, return true if n is in 1 to 10, okay, or if, okay, outside mode is true, right, and you gotta make sure you put parentheses here, n is less than or equal to 1, or n is greater than or equal to 10. So I want to make sure you guys understand the pseudocode. So again, I'll give you guys a minute to kind of understand this. So now that you guys have reviewed over that, now I want you guys to turn the pseudocode into actual code. This can be a little hard at first, so it's perfectly fine if you don't get it right when you run it, and then I'll go ahead and do it with you. Alright, so now to turn this into actual code, so we go to the new line, we return true if n, okay, so we write 1 is less than n or n is less than 10, right? So that's pretty simple code. Or if outside mode is true and n is less than or equal to 1 or n is greater than or equal to 10, else we return false, right? So we go ahead and whoops, must have done something wrong here. Oh, there's no such thing as is if outside mode, and we cannot repeat our if statement here. Oh, we got some cases wrong. Again, this is completely fine, and this is meant to be a learning process, so it's perfectly fine if you get it wrong the first time, right? So so we have to remember, if outside mode is equal to true, right, then this case happens, right? But if outside mode is not equal to true, we have to make sure that we account for that case. So we got rid of one of the wrong cases, so we are on good track. Now we see over here, in 1 to 10, we have 1 in false. So we have 1 here, right? And then we also have false. So outside mode is equal to false, right? And is n, 1 is less than n, which is less than 10. So that's the current inequality we have, right? And we can check over here. Gotta make sure you put down your parentheses. Right, so putting down parentheses is not only for you, but also to make sure you properly, I guess, record and be able to go through the code, and so the program doesn't accidentally run things out of order in some way, right? And we forgot the equal signs there. Whoops. Remember, we cannot put equal after that, and then we get the cases right. So that was typical debugging right there. That is a very, very common process that you will go through as a programmer, right? And when you go through this process, remember, never panic, right? Just take your steps slowly, and over time you'll get faster at debugging. That was a fairly quick debugging process. You won't always get it that fast, right? Sometimes it'll take much longer than other times, right? And that is perfectly normal, right? There's nothing wrong with that whatsoever. Now, what you do need to understand though is when we go ahead and we run this, and we test it out, and we try and make sure we get all the cases. That when you go ahead and debug, many times you get most of the cases, right? If you don't get most of the cases, then you probably did something majorly wrong and you have to check back with your logic. But it's fine for you to just go ahead and create cases. Now, CodingVat is great because it goes ahead and actually makes cases for you. But many times you won't get cases and you'll have to make them up. And since most of these programs, it's actually possible to make cases for yourself, right? Go ahead and do it. Don't cause yourself more trouble than you need just because you didn't like think of it, I guess, right? And so again, with these, there's only a couple combinations that we can make, so it's not really that hard. So I'll give you guys a little time to kind of look back through this and make sure you guys really understand the process that's going on here. Alright, so hopefully you guys understand that process. So if anyone has any questions, feel free to ask them right now. And if nobody has any questions, thank you everyone for watching this class. So we went over two major problems today, and we demonstrated how to debug, how to use your pseudocode, and next week we will finally be able to move on to the next different topics. Alright, so again, thank you for watching. If you have any questions, don't be afraid to ask. It's always okay to ask more questions. And I guess thank you everyone, and see you guys next week. Alrighty, adios.